Hello, in this video I'm going to look at the sum and difference formulas for sine and cosine. Now, for the most part, what we're going to do is we're just going to actually just look at the formulas for each of them and just kind of know how to use them. Now, you can actually derive these by using the distance formula respectively for each of these. Though, let's go ahead and just look at the first one, like cosine of A plus or minus B. Now, the formula actually states that it's going to be cosine of A multiplied by cosine of B. Now, basically, this is where it gets a little funny. You have that for plus, it's going to be minus, and for minus, it's going to be plus. Now, that's going to be sine of A, and then you have sine of B. Okay, so that's going to be the first formula. Now, the second one is actually a lot easier technically. So you have sine of A times cosine of B, and actually when it's plus it's plus, when it's minus it's minus. So you have sine of B times cosine of A. Now, how you might actually use this particular formula, for instance, is say, for example, you have a statement like cosine of, let's say, like pi over 2 minus x. Well, how you would expand this, you would basically say that you have cosine of pi over 2 multiplied by cosine of x, but then it would be plus sine of pi over 2 times sine of x. But basically you have that cosine of pi over 2 is actually 0. And sine of pi over 2 is actually just 1. So really you have 0 times cosine of x plus 1 times sine of x, which basically means that this is equal to sine of x. So essentially you have that this in a way is proving that these two are cofunctions of each other by using the sum difference formula for cosine. Now, another, way that you could probably look at this is, for example, I could look at it like if I have cosine of 90 degrees, I might actually rewrite it as cosine of 30 degrees plus 60 degrees. And then from there, I would go about, expanding it, where I have cosine of 30, and then I have cosine of 60 minus sine of, let me see, yeah, sine of 30, and then multiplied by sine of 60 degrees. Now, basically, the interesting thing about this is that you would have that essentially cosine of 30 is root 3 over 2 multiplied by cosine of 60, which is 1 half, minus sine of 30, which is actually going to be also 1 half. And then cosine of 60 is going to be root 3 over 2. But you'll notice that that just gives you 0. So in essence, cosine of 90, we could have just said, yeah, that it in fact is equal to 0, because if we look at the unit circle, we have that at the top of the unit circle that, yeah, cosine of 90 would be actually 0. So this is a little bit of, overkill to show that, cosine of 90 using the sum difference formula is actually just going to be 0. Now, one thing to make note of is that whenever you're expanding any expression, you're probably going to end up referring back to those triangles, of which you have the 30-60 triangle, or the we have the 45 90 triangle. So like this would be 45, and that'll be root 2, and that's also 45 degrees. Now keep in mind that you should probably be using radians. If not, using degrees should be okay for now. Okay, now I want you to basically look at the following. So let's say that we want to evaluate, cosine of 75 degrees. Okay, so we want to look at cosine of 75 degrees. So how do we do that? Well, to do this, essentially, we just need to say that we need to find two measurements in the unit circle that we know of that add up to 75, or in any combination, their difference is 75 degrees. Now, for me, the easiest way to do that is just 30 degrees plus 45 degrees. You can use like different ones, for example, but in either case, this should be suitable. I actually need, yeah, I actually need this right here. So maybe we'll just leave it. Okay, so let's say that we go ahead and expand it. And okay, so we're basically saying that this expression, cosine of 75 degrees, is going to be cosine of 30, cosine of 45 degrees. It's not plus, it's actually minus, because yeah, when it's plus, it's minus. Minus sine of 30, and then we have cosine of 45 degrees. Now, using our triangles right here, we can actually just substitute respectively. So the first one is root 3 over 2. The second one is root 2 over 2. And then, respectively, sine of 30 is just 1/2. And then cosine of 45 is just 1 over root 2, but that's the same as root 2 over 2. I mean, you do this so many times that you kind of already figured out that the rationalization of 1 over root 2 is root 2 over 2. So you have root 6 minus root 2 all divided by 4. And that's it. Now, keep in mind that, for example, that if we would have plugged this into a calculator, it would have gave us the exact same thing. But you have to realize that most of the time you want the exact answer, or you're asked to get the exact answer. So with that, try to be careful with how you find, the exact values for this. Um, but if it doesn't say, then yeah, clearly you can just plug it into a calculator. Okay, the other thing that I will make note of is that you should definitely try cosine of 15 degrees. Okay, now I'm only going to say to try cosine of 15 degrees because basically what ends up happening is that most of these will all look very similar. So like for example, I've already kind of gave a reference angle in a sense, like 75 degrees. So for instance, if I wanted to know uh, a particular value, like cosine of 105 degrees, well, in this case, I would know that I can expand it as cosine of 60 plus 45 degrees. But I already went through the process of finding, for example, that if I was to look at the angle measure, 105, so 105 is basically relative to 180, it's 75 degrees. So in that case, the angle, it's going to look something like that, where you have that 105 is slightly over by 90 degrees. So in that case, that's 15 degrees. But check this out, okay? So our point, or my point, is that this is 105 degrees. What is this angle on the other side of it? Okay, well, this other angle on the other side of it is actually 75 degrees. So what that means is that if I was to use cosine of 105, I can actually furthermore say that this is the same thing as cosine of 75 degrees. However, where is it at? It's in the second quadrant. What is cosine? It's negative. What is cosine of 75 degrees? Well, it's up over here. So that means that the answer is actually just root 2 minus 6 all over 4 without doing any other extra work because, it's been established what cosine of 75 is. So with that, that means that with cosine of 15, you'll have a reference angle in that sense, okay? Now, that goes hand in hand also in particular like with cofunctions and whatnot. So with that, that means that if you already know, let's say like cosine of 75, then technically that means that you know sine of 15. Okay, but we'll kind of get there. Okay, so similarly, let's say that we try to use um, the formula for using for the sine. So if I was to look at sine of, let's say, 135 degrees. Well, for this one, I know that sine of 135 is the same as 90 plus 45, for instance. And if I was to use the formula, I would have that that's going to be sine of 90 degrees, sine of 45 degrees, and then I have that that's going to be cosine of 90 degrees times cosine of 45 degrees. But I already know that cosine of 90 degrees is actually 0. So in that case, I already know that that's 0 and that this is 1. Now, notice that basically that this all reduces down to 1 times root 2 over 2 plus 0 times root 2 over 2, which is actually just root 2 over 2. Now, again, that's a little bit of overdoing it, to say that it's just going to be sine of 45 degrees, right? Because you know that 135 is in the second quadrant, but what's the reference angle? 45 degrees. So sine of 45. What's sine of 45? Root 2 over 2. So you can kind of see like how those are um, just it's really overdoing it when you're looking at angle measures that you already know on the unit circle. But let's say, for example, that we look at a different angle measure, for instance. So let's say that we want to evaluate sine of 165 degrees. Okay, so if we want to evaluate sine of 165 degrees, well, we can actually compute this very easily because we happen to know, for example, that 165 is the same thing as, let's say, 120 degrees, and then we have 45 degrees. Okay, now if we do this, this is actually going to make the problem, well, it's going to introduce some ideas of you're going to have to basically kind of know the locations of each trigonometric function value. So you have sine of 120 plus 45 degrees is equal to sine of 120 cosine of 45 degrees, and then we have plus sine of 45 degrees and then cosine of 120. Now for each of these, you have that there is a particular value for each of them. So we'll try to do this slowly. 120 is in the second quadrant. The reference angle is 60 degrees. So that's going to be root 3 over 2, and it's positive. Cosine of 45 degrees is going to be root 2 over 2, and it's also positive. Sine of 45 is also the same thing, it's root 2 over 2. But cosine of 120 is actually going to be negative. Okay, well, it's going to be negative because it's in the second quadrant, but cosine of 120 is has a reference angle of 60, so that's going to be negative 1 half. So this gives us root 6 minus root 2, and this is all divided by 4. Now, I don't know if probably you might be wondering, but isn't that just the same thing as one of the answer choices or answers that we found earlier? So sine of 165, um, sine of 165, you have that the reference angle would be 15 degrees. So that means that basically you have that sine of 165 is actually equal to sine of 15 degrees. But sine of 15 degrees is the same thing as cosine of 75 degrees because you have that they're cofunctions of each other. Go back over here and we already have it. Root 6 minus root 2 over 4. Okay, so in that case, it helps to kind of have some of the, you know, uh, some of the angles already made out, for example. Okay, now let's go ahead and try another one. So let's say that we have, for example, that we want to evaluate sine of, okay, so in this case, let's say that we have um, 255 degrees. Okay. Now, 255 degrees. So 255 degrees is definitely in the second, no, it's in the third quadrant, okay? So all we have to do is just think of angle measures that add up to 255. Now, I know 120 plus 135, that adds up to 255, so maybe that'll work. So let's see, we have sine of 120 degrees plus 135 degrees. And this is equal to, let's see, we have, okay, so we have that this is going to be sine of 120 and then cosine of 135. And then we have that, we're running out of room, right? So let's just go ahead and squeeze that in. So we have plus sine of 135, and then we have cosine of 120. Now, basically cosine of, or sine of 120 is going to be root 3 over 2 multiplied by cosine of 135, which is negative root 2 over 2. And then we have sine of 135 is going to be positive root 2 over 2. And then cosine of 120 is going to be negative 1 half. Now in this case, this gives us, it gives us negative root 6 divided by 4 minus root 2 divided by 4, which means that essentially it's just going to be negative root 6 plus root 2 all over 4. Now, keep in mind that basically if you were to kind of like look at sine of 255, 255, if you were to draw your x and y axes, you would have that 255 is like relative to the y-axis. It's like 15 degrees like that. So you have that 255 would look like this. So that's 255. But notice that the angle measured that lies underneath here between 180 and 255 is actually 75 degrees. So in that case, that means that the angle measure is the same as sine of 75 degrees but negative. So you have sine of 255 is equal to negative sine of 75 degrees. However, basically, I wonder, did we already get cosine of 15? I think that was like one of those things where I just said, try it. Yeah. Okay, so if you go ahead and you try to find a cosine of 15 degrees, you'll basically find sort of the same thing. So this is also the same as negative cosine of 15 degrees. But if you go ahead and you find cosine of 15 degrees, you're basically going to find that it's the same thing that I have up there as root 6 plus root 2, all divided by 4, and then you just close it. Okay, so you'll see that like basically that there are some advantages to knowing some of those angle measures. Okay, now what I want you to do now is to go ahead and try. So go ahead and try sine of, let's see, 1,000, uh, well, let's write it like this, 1,425 degrees. Now, to kind of like help you, I'll kind of just say, well, first off, you would need to find what the coterminal angle is. So you can basically just say that, well, if you take 1425, and you subtract 360 the appropriate number of times, that it is going to give you that you have 3 complete rotations, and then you have that what gets left behind is the 345. But then from there, now you know that it's the same as sine of 345. So basically, it's almost like saying find sine of 345. However, sine of 345 is in the fourth quadrant, so you know it's going to be negative, and that's going to be sine of 15 degrees. Okay, so in that case, all that you need to do is just find whatever sine of 15 degrees happens to be, and then that'll simplify nicely. Okay. Um, Now you can use the sum formulas to basically uh, prove identities also. Okay, so just be sure that you're kind of okay with that. And then I'm gonna use another video to show you how to work with radians.